Oh, hi! Thanks so much for showing up for your math learning. Today we are looking at part of we're going to start dissecting the quadratic formula from yesterday. So just to recap, the song goes, just kidding, I'm not going to sing it every time. I can resist that sometimes. But you do want to sing this, at least in your head, so that this starts just to become part of your brainal architecture and it doesn't go missing when you don't have it. Notice we have written the quadratic formula twice. The only difference is we have the plus and the minus separated out. You can do that. It's a little more efficient to just do the plus minus, but this is true. There's two separate answers, and you can write them as separate answers. And the nice thing that we have here is that this sentence is reminding us that the quadratic formula tells us the roots, and they are R1 and R2, okay? There's no D2, so don't start that. But if you find a punchline, let me know, because my brain is real slow this morning. Okay, so there's root 1 and root 2, and they're separated by all this business, okay? This business separates the roots. So if you think about a sketch of some random quadratic that I'm just sketching out over here, all right, we would have this axis of symmetry go up the middle of the quadratic, and everything is symmetrical around that axis of symmetry. So this bit here, actually with it divided by 2a, that's the plus one, so that's going this direction, separating you from that axis of symmetry. But then on the other hand, this one is minus this one, and that would say go that way from the axis of symmetry. And that's where you get the separation between your two roots is from that whole business. All that stuff underneath the square root sign says go to the positive direction or pull to the negative direction. Okay? For those following along at home, that also implies that, he says, trying to pick a good color, this minus b over 2a, which is common to both of these, that's the midpoint that we're dividing away from. So that is, in fact, the axis of symmetry. So, yes, that will be a Monday topic, and how we can use minus b over 2a to find the vertex of these quadratics without completing the square. It's so great. We don't have to complete the square every time. Okay, so that is some anatomy of parabolas lesson, and then we have this part here. We call this the discriminant. Okay, this is a new vocabulary word. If we were if this were an English class and we encountered this word discriminant, what are some things that you can tell me about the parts of that word that might give you clues to its meaning? It is a noun, discriminant. You know any other words that sound like that? Discriminate, yeah, okay. And what does discrimination mean? To discriminate, yeah. And that's based on discrimination, which also means to discriminate, which is, wait, we're in a loop. We're in a tautology. To separate things. To discriminate night from day, or to separate one thing from another thing, yes, would be to tell the difference between. So the discriminant tells you the difference between the roots. It separates things on the parabola. And it helps us talk about what we call the nature of the roots without solving the equation. Okay? So, did people get a nice little sketch there? Another thing we could do to improve our sketch is this is R1, and this is R2, and this is the vertex here, HK. So a few significant points there. All right? And this one tells us R2, and this one tells us R1. All right, let's keep going. So, we have three different ways that we can kind of arrange a quadratic on the xy plane. It has to do with where the quadratic is in terms of how up or down relative to the x-axis. All right, so one situation we might look like this. I encourage you to sketch these along with me. I really want to get math students more comfortable with really rough sketches. Pictures of your ideas, not super accurate math diagrams that you hate drawing. Okay? when the discriminant here is less than 0, here's what happens when I try and take the square root of a negative number. Okay, I could tell you that we can't do it, but you won't believe me. Here is the number, 16, but it's negative. Let's take its square root, everyone. What's going to happen? It says it's invalid. I can't do that. Well, that's weird. I thought something like 4, but negative, if I squared it would, negative 4 squared is 16. What if I square just 4? Okay, and I'm just going to square 4. Oh, it's also 16. There's no number that squares to a negative number. So, algebraically, if this thing underneath your square root is negative, we can't solve the quadratic formula with real numbers. We would need imaginary numbers, that is to say, can't do it, okay? You can't do it yet. You'll learn about it later at university if you study electrical engineering. Okay, so that situation is like this. Tell me, where does this quadratic touch the x-axis? Answer that question for me. Oh, it doesn't. Okay, that would be a situation where we have this type of thing happening. We've been looking at all of these quadratics which are factorable. We built them to be factorable when we played factor magic. Those will always cross the x-axis. They're factorable. There's ways to find those numbers. This one we don't. We don't have it. Okay. There's another one where this is a positive quantity. Okay. If this is greater than 0, then we have this type of situation where here is our x-axis, here is our y-axis, and we might have this quadratic, boop, 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 where we have two separate roots. Or we might have this quadratic, also two separate roots. Okay? Might be opening upwards, might be opening downwards, but it sure as heck crosses at both spots. Okay? This is like a bird flying down to poop on your head. This is like a bird flying down to dive under the water, get a fish, and then come out of the water. Okay? The one bird doesn't go below 0. The other bird does. Okay? And then, and that would be like, where this one is a positive quantity. So if we have like a positive square root, let's say I take an even really small number like 1 and I take its square root. Oh, it turns out the square root of 1 is 1. Even a really small positive number will have a positive square root. That means there's a difference between the two roots. There's some discrimination between the two roots. They're separated by that amount. If we have this rare but very possible scenario where b squared minus 4ac is exactly 0, okay? Then we take the square root of 0. What number when squared gives me 0? 0. So the square root of 0 and like the 10th power of 0 is also 0. 0 has that cool property. So does 1. Okay, anyway. In this case, there is no discrimination between the roots. There's no separation or distance. So these types of situations look exactly like this, where you have the bird come down, touch the surface of the water, and immediately go back up, or the fish come up, touch the surface of the water, and immediately go back down. Okay? They have exactly one root, and that root is the vertex. Okay? So parabolas that have their vertex on the x-axis, the discriminant will tell you that. The discriminant will tell you that by being exactly 0. Okay? And their roots will be negative b over 2a. Okay, that's where you will find them, because of course negative b plus or minus 0 over 2a will be the result of the quadratic formula in that case. So we don't need to do plus or minus 0, you're saying with complete accuracy. I'm 45 plus or minus 0 years old. I just told you very accurately my age in no uncertain terms. I wasn't even rounding to the nearest 5 years. There's no error bars around that. It's just exactly 45. Okay, so now let's see how we might apply that. We can apply that to very quickly get an idea about the nature of the roots and if there's some separation. Okay, so here, let's see, x squared minus 6x plus 9. We want to know the nature of the roots, meaning are there 2 of them, 1 of them, or exactly 0 of them? So here we're going to go b squared minus 4ac. It's kind of like, you know, the DJ is scratching with that part of the record, all right? It's just b squared minus 4ac, and then we plug in here. So here, make your little chart all the same. A is equal to 1, b is equal to minus 6, c is equal to 9. Make this little chart. Some of you are stubbornly not making that little chart and making errors. Okay, so here we go. B squared minus 6 squared. Do I have any errors yet? How's that looking? Somebody tell me what I did wrong. Need brackets. Need brackets around that minus 6 because it's negative 6 all squared, not negative 6 squared, okay? Which would be negative 36. This one is positive 36. So here I have 6 squared is 36, and 4 times 1 times 9 is also 36, so I have 36 minus 36. Last time I checked, that's equal to 0. So this one, I can get a pretty darn good sketch of it. It crosses the y-axis at 9. Here it is up there. This number tells me it goes down, and it has exactly one root. So this root is something like this. Boop. And it goes up like that. All right. I know it has one and only one root. Its vertex is right on the x-axis. That's going to be a very good sketch of that quadratic, particularly if I start labeling points. All right. Ooh, here we've got one where a is not 1. Okay. So, another thing I could do here, if I'm being a little more formal, I might say since the discriminant equals 0, this quadratic has one root. Okay, how about this one? Well, we're going to make our little chart. A equals 3, B equals 5, C equals minus 2, and then copy out b squared minus 4ac. Yes, copy the formula every time. If you sing it to yourself every time, I think that's double the learning. You're writing it with your hand, you're hearing it with your ears, you're feeling it with your body. Okay, because it's just that good of a groove. All right, so then we've got, this is equal to 5 squared multiplied by minus 4 times 3 times negative 2. What does this work out to be when I evaluate it with BEDMAS? Okay, 5 squared is 25. Minus 4 times 3, well, we're going to have minus 12 multiplied by negative 2. And then what will we have? Yeah, we'll have 25 plus 24. Ooh, that's interesting. That's 49. Anyone know any facts about 49? It is a square. So if your discriminant is a perfect square, that's going to mean that you have an integer value when you take its square root. When we take the square root of 49, it's going to be exactly 7. We're going to have plus or minus 7 over top of some stuff. So these roots will be rational. We could have factored this quadratic when that's a perfect square. That's when you know it's factorable. Discriminant perfect square, it's factorable. Cool tip. Okay, but because b squared minus 4ac is greater than 0, we just learned that that thing is greater than 0. I think we can all agree that 49 is greater than 0. 49 is even greater than 45. I wonder where I'm going to be 4 years from now. Okay, so that tells us that we have this type of situation. Boop, boop. Okay, this tells me it crosses at minus 2. This tells me it opens upward and it's kind of bendy. This tells me that it's rising as it crosses the y-axis. So it looks like this. Oh, so of course it has 2 roots because it opens upwards and it starts below the x-axis. So that will always cross. Yeah. So it looks like that. There's our 2 roots. So let's write a little statement about that. I like working in Halloween colors. This is fun. Since the discriminant, and you could write b squared minus 4ac, it's less letters, is greater than 0, this quadratic has 2 roots. Like that. Let's keep going. How about this one? Let's make a little chart, everybody. Let's work in blue. It's my favorite color. A equals 2, B equals 1, C equals minus 5. Somebody put your... It should be like really fun, guys, to point out, hey, Mr. Jennings, I think you made an error. It's so fun. Yeah, what's my error? I made one. Yeah, I have a tell, right? I wait and I look at you funny. Yeah?
And then you say, guys, why aren't you pointing out that I made an error?
C isn't -5. There is no C value.
There's not a C value yet. Usually we would need to have this set equal to something first. We want it set to 0. Is it set to 0 right now? How would we set this to 0? Add 5 to both sides, and then it's going to start looking real familiar. We're going to have, working horizontally for a second, 2x squared plus x plus 5. Is plus 5 the same thing as minus 5?
No.
Of course not. So, C is not -5, it's plus 5. There, fix my error. Very good. So, set things equal to 0. Make them look familiar if they look a little unfamiliar. Okay, use your algebraic manipulations to get what you want in life. All right, then we have b squared minus 4ac. And we're going to plug in. B is 1 squared. Put it in brackets if you want. Don't make a difference here. Minus 4 multiplied by 2 multiplied by 5. What's going to happen here? I know I'm excited as well. Okay, so this is going to be equal to 1 squared is 1. What's 4 times 2 times 5? Someone do it really fast. Just impress us. Huh?
40.
Good. Good job. Did you do 2 times 5 to make a 10 and then multiply it by 4? Or did you do 4 times 2 to make an 8 and then 8 times 5?
Sure.
Both are fine. Is it plus 40 or negative 40?
Negative?
It is indeed negative 40. What's 1 minus 40?
Negative 39? No. Negative 39, yeah.
Is that bigger than 0 or smaller than 0?
That's small.
So b squared minus 4ac is less than 0. We just learned this, okay? We just learned this by crunching that. Notice the difference that this c value being positive 5 instead of negative 5 would make to our answer. Okay? If we had negative 5 up here, this would then be positive 40, and that would be 41, definitely bigger than 0. We would be wrong. So be right by doing things carefully and making sure that you set things equal to 0 and just do all the steps. Okay? You can't miss steps and stuff. Can't skip steps in life. So here, let's have a sketch of what we've got here. All right? We have this quadratic. It crosses up here at 5. It's rising gently as it crosses like this. And it's turning around pretty quick. It looks like that. It's way, way high over top of the x-axis. Watch what happens if instead I had that down there at minus 5 erroneously. It would still have the shape that it does otherwise, but it would definitely have 2 roots. Okay? And those 2 curves would be parallel despite my grody sketch there. So it's not this, it is definitely that, and we would say, since b squared minus 4ac is negative, this quadratic has no roots. What if we've got algebra in our coefficients? These coefficients all got mixed up in some algebra, okay? And the teacher that created this said they have equal roots, meaning like R1 equals R2. Another way of saying that would be b squared minus 4ac, negative b plus b squared minus 4ac over 2a is equal to negative b minus b squared minus 4ac over 2a. Okay? If the two roots are equal, it must mean these two things are equal. If those two things are equal, what does that tell you about b squared minus 4ac? Over here I'm adding it, over here I'm subtracting it, and it didn't matter. If I added it or I subtracted it, it didn't make no difference. It's 0. Good. Yeah. So that tells you b squared minus 4ac equals 0. Okay? If I were making this question, I would have said has one root. That's the same thing as having like two equal roots. They're the same thing. Okay? It's the vertex. So that is to say, b squared, we are asked to find the value for k such that b squared minus 4ac will equal 0. Okay? So let me just get rid of all this. That's just kind of me riffing about the weird way this question was asked. I actually misinterpreted it when I put this thing together, but this is a better question anyway. Okay, so then we're going to make our little A, B, and C chart. All right, now they're not just numbers. Now I definitely advise you to make your A, B, and C chart. What's the value of A?
1. Oh.
We don't know yet. So it's K. What's the value of B? K plus 8. Very good. And then what's the value of C? 9. All right. We are looking for the value of K that makes this thing equal to 0. So let's go ahead and sub it in. K plus 8 squared minus 4k9 equals 0. It's supposed to be fun, everyone. It's the interactive part. Hey, Mr. Jennings. You made the same mistake again.
Oh no.
What didn't I do? Where? K plus 8 needs to be in brackets. Oh, I square the whole thing k plus 8, not just 8. Okay, that's going to be very different. Watch. So my next line is going to look like this. This is equal to k plus 8 multiplied by k plus 8 minus 4 times k times 9. Can I simplify that?
Yes.
What would it be? 4 times k times 9 is the same thing as 4 times 9 times k.
Negative 45k.
Well, I was going for 36, but yeah. 4 times 9 is 36. Yeah, so there we go. So now that's as simplified as we can get. And that's all equal to 0. Cool. Okay, k plus 8 times k plus 8. Let's go. K plus 8 times k plus 8 is k squared plus 8k plus another 8k. Are there 8k TVs already? Or are we just still at 4k? 8 times k, so there I've got those. Plus 36. Sorry, plus 36, plus 64. Sheesh. Minus 36k equals 0. Okay, cool. Now I can simplify this. K squared plus 16 minus 36 plus 16 minus 36 gives me minus 20. Minus 20k, and if you don't believe me, your calculator tells you the same thing. Plus 64 equals 0. Oh my God! I got a quadratic in terms of k. And it's already equal to 0. And we get to solve it together, everybody. Isn't that great? We get to solve this together. All right, so how do I solve a quadratic like this? K squared minus 20k plus 64. Oh. We're going to win an X game. We're going to multiply to 64 and add to negative 20. Want the Jeopardy music? Does it help you think?
Yes.
Do, 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 do. What are they? 8 times 8 doesn't work, right?
It's 4 and 16.
16 and?
4.
Yeah, good. Negative 16 and negative 4 will work. Okay, 8 times 8 won't work because that would add to 16. So think of it as 2 cubed times 2 cubed. That means 64 is equal to 2 to the 6. And then try the next rearrangement. Peel a 2 away from here and put it over there. 2 squared times 2 to the 4. That's 4 times 16. It's the same thing as 8 times 8. It's 64. It works. So then we get k minus 4 times k minus 16 equals 0. Hooray! And that's and this will give us the values of k. So what are the values of k that make this quadratic have 0? Find the value. That's interesting. The values. There are 2. What values of k give this quadratic equation exactly 1 root? What are the values of k that solve this? Solve now for k. We factored so that we could solve. So now solve. If k minus 4 equals 0, what's the value of k?
4.
K is positive 4, good. And if k minus 16 equals 0?
Positive 16.
Good. There are 2 values of k that make this question go. Okay? So, notice when I wrote down the questions for you to practice, I mentioned a very helpful tool that can help you visualize the role of the discriminant in changing these quadratics. I'm just going to pause the video. You guys go ahead and get started on your work, but I'm going to prepare a little Desmos visualization of the question we just looked at. And then you'll see that how that k value makes it have exactly 1 root for both those values. Okay, any questions? Put your hands up. Did someone just say nothing's worse than this? Is this lesson that bad? Okay, here. This is how you can investigate this stuff in Desmos, okay? I just typed that in. I should have shown it on the video. Let me remove this. Watch. If I type that in, I just type it from the question, and it offers to create a slider for me. The slider can show different values of k. As k changes, you see the shape of the quadratic changes, right? And then it does this weird thing. Watch here. When k is 4, we get exactly 1 root. Look at that. When k is 4, the root is minus 1.5. Okay? We didn't find the value of the root, but we found that it has exactly 1. And then if I set k, I can do this and just highlight it. Set k to 16, and it's down there. Cool, eh? And then I can see as k is between 16 and 4, it kind of traces a parabola there. Isn't that cool? There's your quadratic in terms of k. Would be all the locations of that vertex. Is very neat. And then boop, there, 1 root, and no roots, no roots, no roots, 1 root, 2 roots, 2 roots, 2 roots, and beyond there, oh yeah, I can't go beyond that, but if I did 1600, you'll see 2 roots. Yeah. Okay. So that's how you investigate. Investigate all your questions in Desmos, everyone. Just dump stuff from the practice into Desmos so that you can build your visualization muscles. And thanks for showing up for your math learning.